how to check your solution to a linear differential equation. It's pretty straightforward, pretty simple. If we're integrating to find the original solution to a differential equation, if we take the derivative of our solution, we should obtain our original differential equation. So let's go through the steps. Now there's multiple ways to do it. I'm going to be using the product rule, which is this formula right here, and I'll also be using implicit differentiation. So if we multiply both sides, we'll obtain y sine x is equal to negative x cosine x plus sine x plus 1. Now we have a product rule here, but it's implicit, because if we're taking the derivative with respect to x of a variable other than x, then this will be just the regular derivative of y, which is 1 multiplied by dy dx. Now if this was y to the second power, this would be 2y multiplied by dy over dx. But since we only have y to the first power, you don't have to worry about nothing. Notice that there's another product rule, and this is just regular because both variables are with respect to x, which is what we're differentiating. Okay, so right here we're going to be using this formula, and let's go ahead. So this is our f variable, this is our f of x function, so then this must be our g of x function. So it says take the derivative of f of x and copy down g, so let's do that. The derivative of f of x, which is y, we said was 1 dy over dx, and we're going to copy down the g of x function. Now the next step is to take the derivative of the g function and copy down the f of x function. So we're going to add the derivative of sine x is cosine x, and then we're going to copy down our f function. So we took care of the left side, now let's take care of the right side. Now this is our f of x function, so this must be our g of x function. Again, we take the derivative of f of x and copy down g. So the derivative of negative x is just negative 1, and we're going to copy down cosine x. Then we're going to add the derivative of cosine x is negative sine x, and we're going to copy down f of x. And the derivative of this one now, sine x, is cosine x, and the derivative of 1 is 0. So we don't even need to write that. So now let's simplify things. So let's do dy over dx. Let's look up for inspiration to see how this looks. Sine x is before dy dx, and y is before cosine. So let's just write it the way our original function was written, plus y cosine x. This is negative cosine x. This negative and this negative become a positive, so this is plus. And let's put the x in front of it so we don't get confused. And we're going to add cosine x. You notice this and this becomes 0. So what we're left with is sine x dy over dx plus y cosine x is equal to x sine x as expected. So what that means is that we did solve the linear differential correctly, because if you notice, when we take the derivative of our solution, we obtain the original differential equation.